to see some of the stuff that that people, architects are able to achieve. Tēnā katoa, I'm Greg Davies, Managing Director of the Engineering Collective. We're structural engineers just next door, so it was nice and easy to get here for me. So I've been asked to give a talk on a structural engineer's perspective to sustainable design, and obviously the focus on polystyrene. I also won't go into polystyrene in much detail because I'm not an expert, and many have covered that already. And when I first was asked, I sort of thought, why me? And imposter syndrome came in, and I thought, am I like these guys? Don't know if you know who they are. Hopefully I'm not, because I realise I am a structural engineer. I have got a lot of experience, and I've done lots of different projects, of all sorts of types, so I clearly have something to talk about, all sorts of structures. So hopefully what I have to say will be of some use to you this evening. And I guess where I'm coming from is I'm not a sustainability expert or an expert on polystyrene, but I'm an experienced structural engineer. So what I'm going to talk about is the current and potential role that we have as structural engineers in sustainable design, the reality of what it is actually like for us, and really what's going to help close the gap. So obviously, where do we fit in? We're at the front end of projects. We design based on materials, as was discussed before. We really influence the front end of designs. That's where a lot of our thinking is. We do design for durability, and that looks at how the structural materials are used during the life of the building. There isn't a great deal of thought around the end of life stage or reuse, although obviously we look at reusing buildings and repurposing them, but it isn't something that we have a lot of focus on in my practice because we're not asked to. So, what do we control and where's the gaps? System choice, so we obviously are involved in deciding what type of structural systems or materials are being used. And we can do embodied carbon calculations. I haven't done any because nobody's ever asked me to. It's the reality. None of our clients are all that interested. They're certainly not going to pay me the extra time that it takes for us to do that. So that's just the reality that we're living in at the moment. Yep, we can get right-sized material, the members, make sure that our structures are efficient, we're not over-designing, keeping them light, reducing the impact, reducing the amount of materials. And we clearly need to design for durability, make sure that they last the distance and that they're adaptable. But the reality is on-site things are different. And this is an example, a detail from one of our drawings, simple timber beam. We show it with 4 studs, and it ends up with 6 on site. And you can see in the background another timber beam, only really needed 2 studs to support it. It's got 7. And you just, get to site and you wonder, what the hell are we doing? And the way that we interact as a construction industry and the lack of coordination between the timber framing detailer and the structural engineer is limited. And we're just not paid to do that to the level that would make sense. Obviously that then has an impact on the insulation of the house. There's not as much insulation, you've just got lots of solid timber, and you're using a lot more material than we really need to. So we can clearly do better. So yeah, the friction that keeps familiar specs in place, and you were talking about specifications before, it's the same thing really. Construction cost is king. That's what our clients are most worried about. Yes, there's quality and time frames, but cost is really what they're most concerned about, and sustainability is not something that is actively asked for, considered, discussed on most of the projects that we deal with. Obviously, there's also the habit, inertia. It's easier to do it the way we've done it before. Why take a risk and do something different? It's faster for us to price. We know what we're going to get. We know how it's going to go through the consent process. There's no risk there. So it's much easier for us just to keep things the same, even if they're not really working that well. Then there's the compliance pathways. So often for some of the products that we try to deal with, there isn't a compliance pathway. Then there's risk that the client is concerned about. A lot more effort as a consultant to get it through the consenting process. And in reality, the cost on paper is not really the cost in practice, and that's not often considered. The amount of waste, we've seen there the fact of trying to actually demolish a riprap slab it's horrific. I mean, that was very instructive to see that, and quite concerning. Rework in design is obviously another issue that we deal with. And these are not things that a QS is going to cost in to the alternatives that we sometimes try and propose, and that's just the reality that we have. So it's I'm sounding pretty bleak about our role and how we work in it, but there are examples of where it works. So who remembers plastic bags? That was the norm. We all go to the supermarket, you get your plastic bags, pop it in, walk to your car or on your bike. I was living in Ireland when Ireland became one of the first countries to put a levy on plastic bags. And before long, we were all using these. And it wasn't a problem. To start with, none of us could see that change happening. But until it cost you to have a plastic bag, you didn't have an incentive. And I think that's really where a part of what really needs to happen is there has to be a cost associated with doing it the way that has a negative impact, and putting something in place that has a more positive impact. So it can be done. We're all using those recyclable bags. In fact, I've got so many of them now, I don't know what to do with them. And we've moved on to the brown paper bags. I've got a whole bunch of those in my garage too, thinking that I might use them for something. We're already using them in our rubbish bins. So what that helped me to sort of think about is, what are the things that we need in order as a structural engineer to be able to help our clients to consider something that's more sustainable, that has better environmental impacts. The first thing has got to be cost neutral. It's kind of non-negotiable. They're just not interested unless you can show that there's similar costs, and that isn't whole life costs. That's cost to construct. So that's a challenge. Being like for like substitution for something that's already in the market really, really helps. It's got to have the same performance. It's got to work structurally. If the building falls down, I haven't done my job. So that is a non-negotiable. It's got to meet all the other performance requirements of a building, not just the structural ones. And then clearly, if it has a compliance pathway, it's much easier for us to promote them and to help our clients to consider them. So, ideally code mark, and then the other thing I noted at the end there is regulatory incentives. So helping to either promote the use of better materials, or at least penalise people for using materials that are having a cost, like a riprap floor. So if we achieve all of those, then we have an opportunity to actually make substitution a reality and using better products. So an example is the Cleverbot. And obviously, I'm sure Andrew will tell us more about it. But from my point of view, I feel confident to promote it as an alternative, because the costs are fairly much the same. They use less concrete. It's got lower transport costs. Clearly, over life, it's a lot better off. So it's good to be able to talk about that. But from a construction point of view, it's relatively much the same. Like for like, there's other pod systems out there, but they don't match a riprap pod. So it's harder to then build it into your design at a later date. Whereas if a riprap slab is what the client's used to, you bring something that's pretty much the same, can be cut just like a polystyrene pod can. It has the informers, all of those things, makes it easy. Then it's easier for us to substitute it. And it's got code mark. The compliance pathway becomes much easier. So it's an example of where, it's not a sales pitch for me, but it's an example of where we can actually, as structural engineers, be confident to make something work and our clients to take it up. So a little plug for us. We, as I said, are next door. We're a small bespoke structural engineering firm. We do all sorts of buildings. We specialise in difficult ground conditions, innovative foundation systems, innovative products. We work a lot with the high performer building and doing some projects with them around the place. So that we're really passionate about the innovative side of what we do. We've done surf towers with the wild boar footings that you see at the back there. So those are driven into a coral reef. No, not great, but a lot better than big holes full of concrete. That isn't going to last very well. So we used stainless steel on those, driven into the reef. Architecturally designed houses, and we do stone. We also do facade support structures. So those are the sort of projects that we get involved in, but all sorts of things. So to leave you with some key points, structural decisions are really at the front end of projects. That's where we largely can make a difference, and where we can move the needle. So we want to obviously talk with others about how we can collaborate on that. For credible, sustainable solutions, as I mentioned, they need to be cost neutral, like for like, meet the performance requirements, and ideally have a compliance pathway that we can easily go through. But ultimately, it all comes down to collaboration. We can't do it alone as structural engineers. I often feel very powerless, but it's good to talk with others who are keen to look at how we can do things better. Architects, the right sort of developers, property owners, managers, and then obviously I believe that the regulators have a really key part to play in this in terms of incentivising the right sort of construction and penalising the wrong. So that's me. And if you've got any questions afterwards, happy to answer them.